Good afternoon. Um, I'll start with question 7, the last question. So, uh, my data set is the efficiency of three sensors: the lidar, the camera, and the radar. So, I get the efficiency during different conditions, like during sunlight, during darkness, and during rainfall. And so these are the efficiencies for three different sensors. X1 represents the LiDAR, X2 is the camera, and X3 is the radar. And so initially we get, uh, there's an outlier. We carry out, we plot an outlier to see the to we plot a chart to see if there's any outlier, and there was no outlier, so the data is good. And we looked at the histogram to see if the distribution is normal distribution, and there was a slight approximate normal distribution. So I just assume that the distribution is normal from this slight similarity. And so I went ahead to perform the one-way Anova test, that calculates, uh, that compares the efficiency of uh, the the three different sensors. So my null hypothesis states that the means are the same, while the alternate hypothesis states that at least one mean is different. And so after calculation, I got an start that was less than the F critical. So the conclusion was that we failed to reject the null hypothesis, and therefore there is no significant difference in the efficiencies of the sensors. A two-way ANOVA test was carried out, and we were looking at the effect of the sensor type on efficiency and the effect of the climate, the different climatic conditions or exposure to sunlight on the efficiency. And so in the end, for the climate, the absolute was less than the F critical, and for the sensor, the absolute was more than the F critical, and for the sensor, the absolute was more than the F critical. And so the conclusion was that um, the different conditions will have no significant effect on the efficiency, and the null hypothesis is also rejected for the sensor types, and there is no significant difference on the efficiency due to the sensor types. Okay, so question 6 gives us, and so we perform a normality check for question 6, and this is the histogram. And after performing that, we carry out, we declare null hypothesis, which states that the mean from physics is the same as that for chem. And after carrying out the test statistics, we determine that the T stat is greater than the T critical, which implies H0 is rejected, the null hypothesis is rejected. And so here is we also we carry out the Gaussian when we run the two Gaussian data from physics and chemistry. And in the end, T stat, we carry the T test rather. T stat from the table is this, T stat is this, so T stat is less than T critical. So we reject H0. And question 5, again, we carry out the T statistics, and here's our MATLAB code. In the end, the T stat is greater than T critical. So H0 is rejected, and here is our MATLAB code. And so for the Gaussian and simulating the Gaussian, here are different degrees of freedom, and so as we increase the degrees of freedom, you see that the blue becomes more Gaussian, more bell-like shape. So that is um, what happens as we increase the degree of freedom. For question 1, I used a uniform distribution and a chi-square distribution, and after increasing the n value for a very large number to approximate to central limit theorem, we see that the uniform becomes normal distribution and the chi-squared becomes slightly normal distribution as well. And for question 2, here is the function that simulates the Gaussian distribution, and we plot, and here is an approximate Gaussian distribution. So question 3 implements the same function, and we get the confidence interval for different confidence level. So that was the implementation. Thank you.